In this video, we're going to learn how to solve rational expressions. So before we were just learning how to simplify, and now we're actually going to learn how to solve. So we're now ready to solve rational equations, and we're going to apply what we know about factoring and simplifying to solve. So remember, an equation is an equation because it has an equal sign. Without it, it's just an expression. So previously, we were just simplifying for the sake of simplifying. Now our goal is to simplify and then solve for the variable. So note, in a rational equation, if all of the denominators are the same, we can write the equation using just the numerators to solve. So look at this first example. All of these denominators are 7. When that happens, we can just focus on the numerators. So we're just going to write out what the numerators are. Well, the numerators are x plus 3 equals 5, which means the solution to this equation is x equals 2. So now we're going to apply this for solving a rational equation. The first step is to see if you can cross multiply. So is it a proportion? So that means we have something like a fraction equal to another fraction. Let's look at our first example before I move on. My first example has one fraction equal to another. I always like to put parentheses around things that have more than one thing in the numerator or denominator. Since it's a fraction equal to a fraction, this is a proportion, so I'm going to cross multiply. So I cross these, and I cross these. Then I have 5 times x minus 1. Notice how my parentheses are really nice because they remind me to distribute. Equals to 2 times 15, which is 30. Now, because I had those parentheses there, I remember to distribute. So I get 5x minus 5 equals 30. I add 5 to both sides, so I get 5x equals 35. And then finally, I divide both sides by 5 to get x equals 7. Now, most of the time, you'll notice we're not that lucky. In these next two examples, we have a fraction minus a fraction or a fraction plus a fraction. In those cases, we can't cross multiply. So we're going to have to follow steps 2 through 5. Our first step is to factor all the denominators. That helps us simplify. So notice in the second equation, there's nothing to be factored. So let's keep going. The next step is to find the LCD, which is the least common denominator. To do this, we're going to look at the denominators. Now I know this has an x plus 4 in it. So I need to have an x plus 4 somewhere in my LCD. That's one of the factors. It also has an x, so I know I'm going to have an x. Now my last fraction has an x and it also has a 3, so my LCD is going to be 3x times x plus 4. Now I look at my denominators and see what they're missing. Because in my next step, I'm going to change all the denominators to the least common denominator. So to do this, I look at my first denominator. It has an x plus 4, but it's missing the 3x, so I multiply the numerator and denominator by what it's missing. Remember, 3x divided by 3x is just 1, so I'm not changing the equation. My second denominator just has an x, so it's missing a 3 times x plus 4, and on top it's missing a 3 times x plus 4. And last up, my last fraction has a 3x, but it's missing the x plus 4. And remember, you always want to put that in parentheses so that you don't forget anything. All right. Now, my last step, like we did up top, is to just write an equation with the numerators. So my new equation is a 3x times 2 minus 1 times 3 times x plus 4 equals 2 times x plus 4. Now this is a lot easier to solve. There's no more fractions, so I'm just going to simplify and solve. So this becomes 6x, no, minus 3x minus 12 equals, I'm going to distribute here, 2x plus 8. Now let's combine like terms. So this 6x minus 3x becomes 3x minus 12 equals 2x plus 8. And finally, I'm going to subtract 2x from both sides, add 12 to both sides, and I get x equals 20. So there's my final answer. Let's try this again in the next problem. This one's a little bit more complicated, but not too bad. So, first, can you cross multiply? No, because it's not a fraction equal to a fraction. There's a whole addition problem going on in there. Next, we're going to factor. So I can factor the x squared plus 2x minus 8. So this becomes 2x plus 1 over, this is x plus 4 times x minus 2, because 4 and negative 2 multiply to negative 8 and add to 2. Now everything else is already all set for me. And I like to put these in parentheses. So now let's figure out what the LCD is, or the least common denominator. Well, I need an x plus 4. I need an x minus 2. And then it looks like I have everything else covered. So now I'm going to multiply by what it's missing. My first fraction actually has everything in the denominator already. My second fraction is missing the x minus 2 times x minus 2. And my last fraction is missing that x plus 4. Now that we have the same denominators, I'm able to just focus in on the numerators. So I'm going to just write the numerators now. Plus 2 times x minus 2 equals 1 times x plus 4. Now I distribute and multiply everything out. So 2x plus 1 equals 2x, plus 2x minus 4 equals x plus 4. When you combine like terms and put all the x's on one side, put all the numbers on the other, you end up with 3x equals 7. Now I divide both sides by 3 to get x equals 7/3. So there's my final answer. At this point, we have to watch out for a potential problem. So recall from previous math courses the following. So 0 divided by 5, or 0 divided by any number, if you plug into your calculator, if you ever forget, it's just 0. But 5 divided by 0, or anything divided by 0, is undefined. If you try plugging it in your calculator, you're going to get an error. So remember, we cannot divide by 0. That means if I find some solution, maybe it's like a 7, and I plug it back in, and I find out it makes the denominator equal to 0, it's not going to be a solution. And what we're going to call it is an extraneous solution. So let's see what happens in these next two examples. So this first example, the first thing I'm going to do is factor it. So I can factor the x squared minus 1. Remember, that's a difference of perfect squares. So this becomes x minus 1 times x plus 1. Now I'm going to write out the LCD, the least common denominator. Well, I know it needs an x plus 1, and I know it needs an x minus 1. Nothing more than that. I'm going to multiply now so that I set it up so that all the denominators are the same. This first fraction is missing out on an x minus 1. So I multiply both numerator and denominator. My second fraction is missing out on an x plus 1. Kind of have to squeeze it in. And my last fraction is missing out on nothing. I have the same denominators, so now I'm going to write an equation with just the numerators. So this becomes 3 times x minus 1 equals 1 times x plus 1 minus 2. Now I'm going to distribute and solve. 3x minus 3 equals x minus 1. If I move the x over, move the negative 3 over, I get 2x equals negative 2, which means x equals negative 1 is my only solution. But let's think about the original problem. So you always want to try to plug it back into the denominator. If I plug this back in all the way up here, in that first denominator, if I plug in a negative 1 plus 1 is 0. So x can't be equal to negative 1. So this answer is extraneous. It's not that you made a mistake when you solved, it's that the answer actually didn't work. So that was our only option. So now our answer is actually going to be no solution. Let's try this next one. So, can't cross multiply because it's not just a fraction equal to another fraction. So I'm going to try to factor so that I can easily see what the LCD would be. I'm just going to factor the denominators for now. So I'm going to factor that x squared plus 2x minus 3 into an x plus 3, x minus 1. How convenient. So our LCD, we know we need an x plus 3 in there. We know we need an x minus 1 in there. And our last fraction has everything covered. Now I'm going to write it so that it has a common denominator. This first fraction is missing out on the x minus 1, so I'll give that to him. Second fraction is missing out on an x plus 3, so he gets that one. Last fraction already has everything. Now that I have common denominators, I'm going to rewrite with just the numerators. So I'm going to write this as 2 times x minus 1 minus 1 times x plus 3 equals negative x squared minus 3x. Now let's distribute so that we can simplify. So I get 2x minus 2 minus 1x minus 3 equals negative x squared minus 3x. Combine like terms, so we end up with x minus 5 equals negative x squared minus 3x. Notice this problem is a little different from the problems we solved before because this one has an x squared in it. Now remember back to solving quadratics. One of the ways we can solve by quadratics is making everything equal to 0 and then factoring. So let's see if we can do that. So what we're going to do is add x squared to both sides and add 3x to both sides. And what do we end up with? We get x squared plus 4x minus 5 equals 0. Let's see if we can solve this by factoring. What multiplies to negative 5 and adds to 4? That's going to be x plus 5 times x minus 1 equals 0, which means x plus 5 equals 0, or x minus 1 equals 0. If we solve these two equations separately, we have x equals negative 5, or x equals 1. Last thing we have to check is that we can plug these in. Go back up to your original. If I plug in negative 5 into the denominators at the top, that's fine, right? There's never anything that's going to cancel out to make it 0. But if I plug in 1 right here, 1 minus 1 is 0, can't have that. So that one is extraneous. And my only solution is going to be x equals negative 5.